When it comes to solving for a variable, sometimes the choice is easy. If there's already a variable that doesn't have a coefficient in front, that's an easy one to solve for. But sometimes it's tougher. Let's take a look here at this case, and I'll give you a tip. As you're looking at all of this, well, this x has a number in front, so does this y, so does this x, so does this y. Everything's got numbers in front. We're going to have to divide at some point to get one of these variables by itself. If you can, let's see if we can find one that helps us avoid fractions. The way to do that is to try and find a number that divides evenly into all the other coefficients in the equation, all the other numbers. For example, look at the bottom equation. If I want to solve for this x, I'm eventually going to have to divide by this -4. But 3 doesn't divide nicely by 4. It's going to give you a fraction. 15 doesn't divide nicely by 4. It's going to give you a fraction. That's not bad. It's just harder to work with. So I recommend this. Let's see if we can find a number that does divide evenly into the others. Like, let's take a look here at the top x. To get this x by itself, I'm going to have to divide by this -4. But as I look at the other numbers, 8 will divide evenly by -4, because 8 divided by 4 is 2. And this 4 will also divide evenly by -4, because 4 divided by 4 is 1. So let's just look at the first step of this process. If I want to take this top equation and get this x by itself, then the first thing I would do is move the y's to the other side. And I'm then left with -4x equals 4 minus 8y. And now comes the division by the -4. Now, when you're doing this division, you must remember those divide down to 1, but take each of these numbers divided by that denominator. 4 divided by -4 is -1. -8y divided by -4 is +2y. From here, then, you would take this x, substitute it into the other equation, and solve. We're going to stop here because I just wanted to show you that tip of how to find an easier number to divide by. There are two special cases I want you to be aware of. Let's take a look at them. Here's the first. Thankfully, this first step is already done for us. I've already got this variable by itself with this on the other side. So I can now go to this top equation, and where I see the letter y, I can replace it with 3x minus 4. Let's see what happens. So -6x plus 2 times y. And remember, I'm replacing this y with its equivalent expression, the 3x minus 4, and that's equal to 3. Simplify, so the 2 times the 3x, the 2 times the -4. Right now, just simplifying, so -6x plus 6x, that's 0 x's, so no more x's are left. I've got -8 equals 3. So I'm at a point where there are no variables left, and I've got an equation that doesn't make any sense. Let's take a look at a graph and see what's going on. Something seems to be a little bit funny. Here's my top equation, -6x plus 2y equals 3. And now my bottom equation, y equals 3x minus 4. This is what's happening. The reason I got an equation that didn't make any sense is because this system has no solution. That's two parallel lines. They never cross each other. These systems don't share a solution. That's special case number 1. If you're substituting and you end up with no variables, like we didn't have any x's or y's here, and a false equation, -8 is not equal to 3, that means the system has no solution. You should check it with a graph and see two lines that never cross each other. Special case number 2. Let's see what's going on here. Once again, First step of the process is already done for me. I've already got a variable by itself. This y is equal to this stuff. So in the second equation where I see the letter y, I can replace it with this stuff. So we're left with y from the top being substituted down below. So the bottom equation, negative 24x minus 3 times y, I'm going to replace that with the negative 8x minus 20, equals 60. Now we're going to try and solve for the x. Let's see what we've got. So negative 24x, first distribute the negative 3. So that's going to be plus 24x plus 60 equals 60. Negative 24x plus 24x, group them together. That goes to 0 x's. So I'm left with then 60 equals 60. Once again, no variables left. This time, though, I've got an equation that is true. 60 is equal to 60. Let's take a look at a graph and see what's going on. Going to graph the first equation, minus 20. Okay, so change this to a 9. Let's make this red. And then this next one, negative 24x minus 3y equals 60. Oh, and take a look at that. The second purple equation is right on top of the red one. The reason we got no variables, but this time a true statement, is because it's really just the same line twice. So every ordered pair that makes the first equation true also makes the second equation true. That means this system has infinitely many solutions. Every ordered pair on the line makes both equations true at the same time. So special case number 2. If you end up with no variables, so our equation here, no x's, no y's, and a true equation, 60 is equal to 60, then it's really the same line twice, and you have infinitely many solutions. Now, this isn't on the front of your toolkit, so I would recommend writing information about these 2 special cases on the back of your toolkit paper.